Okay, class, we're starting section 3.11, fractions and problem solving. Okay, section A, solving problems containing fractions or mixed numbers. We will institute the problem solving steps, which is first you have to understand the problem. Second, you have to translate the problem into some type of expression or equation. 3, you have to solve the problem. And 4, you interpret the results. Now below here, we have the table that signifies some of the key terms for addition, subtraction, multiplication, division, and equality. Now, what we could do is this here. You could look at this a little later at your leisure. And these are the words that we're going to apply to a lot of these application problems. Now we scroll down here. Now, this quick hint here. I took the liberty of indicating what these statements mean. It said perimeter means the distance around a figure. It is measured in units. So what I did here was like imagine that the perimeter end up equaling 5 inches. So what I would write is 5 in inches. That's what it means by it's measured in units. Now with our area, the area measures the amount of surface of a figure. It is measured in square units. So I imagine that my area was 5 as well. But instead of being 5 inches, it'd be 5 inches squared, because that's what it means by square units. Anytime you deal with area, your answer is always in square units. Now volume measures the amount of space enclosed by a region. It is measured in cubic units. So anytime you do volume, your units are always cubed. So now we scroll down here to number 1. I took the liberty of filling out part of this here. It says find the volume of a box that measures 4 1/3 feet by 1 1/2 feet by 3 1/3 feet. Okay, the volume of a rectangular prism, which we have here, is length times width times height, which is denoted here. Now what I did here, I labeled each of these values. The length is 4 1/3, the width is 1 1/2 feet, and the height is 3 1/3 foot. So now we have our volume. We're going to substitute. 4 1/3 goes in for the length, 1 1/2 goes in for the width, and the height is 3 1/3. Now our next step, we have to change these mixed numbers to improper fractions. We have 13/3 times 3/2 times 10/3. Now we're going to take the prime factorization of these numbers. You have 13 times 3 times. This 10 becomes 2 times 5. Now in our denominator, all 3 of these values are prime. So now we have the volume is equal to. Now we can simplify out what they have in common. They have one set of 3's and one set of 2's in common. So now 13 times 5 is 65, and that's all over 3. Now, that would be cubic feet. But listen, since we started off with mixed numbers here, if we can make our final answer a mixed number, we're supposed to. So I'm going to go off to the side here and take 3 into 65. 3 goes into 6 twice. Bring down our 5. 3 goes into 5 one time. And we have a remainder of 2. So, well, we were right over here. Now, I know this disappeared here, but you can rewind the tape to get what this was. So we will have our volume is equal to, it will be 21. Our denominator was 3. And our numerator will be the remainder, which is 2. So it'll be 21 2/3 cubic feet. And that is the final answer. Okay, now we scroll down. It says, suppose that 25 acres of land are purchased, but because of roads and wetland concerns, 6 2/3 acres cannot be developed into lots. How many 5 6-acre lots can the rest of the land be divided into? Okay, our first thing that we need to do is to determine how much land we're actually dealing with to develop. Now we had 25 acres. But remember, 6 2/3 cannot be used, so we need to subtract that. So we do not have access to that 6 2/3. Okay, so we subtract here. Now, As I showed you in class, we have a whole number minus a mixed number. And we know we have to borrow 1 from that whole number. So first of all, we will bring over that mixed number. There's nothing we can do with that. So now with the whole number, we know we will borrow 1 from 25. That would give us 24. Now the 1 that we borrow, we will make the numerator and denominator the same as the denominator in this fraction here. So we'll have 24 and 3/3. Now we know 24 and 3/3 is actually 25, so we didn't change the problem. 3/3 minus 2/3 is 1/3. 24 minus 6 will give us 18. So we have 18 and 1/3. But now we want to know how many 5/6 acre lots can the rest of the land be divided into. So we know we would take this value here and divide it by 5/6. So now we change this 18 and 1/3 into an improper fraction. 18 times 3 is 54 plus 1 is 55. So we have 55 over 3 divided by 5/6. So now we'll take 55 over 3. Division becomes multiplication, and we take the reciprocal of the second fraction. Now, we could take the prime factorization of 55, which is 5 times 11, and the prime factorization of 6, which is 2 times 3, divided by 3 is prime and 5 is prime. So now we have one set of 5s in common, and we have one set of 3s in common. So this will give us 22 over 1, and our final answer is 22. Also, let me go back here. I was going to go down to the third problem, but let's clarify something here. Okay, your answer is 22, but what we would need to do, remember, we need to write this answer out. So I write it right here. It'll be let me see. They ask you how many 5/6 acre lots can the rest of the land be divided into, and you could write the land can be divided into 22 5/6 acre lots. Now this is the proper way to answer this question. I know the answer is 22, but you have to write your answer out as a statement. The land can be divided into 22 5/6 acre lots, and that's it for that problem. Okay, now we come down here to number 3. It says in a primary election, 5 candidates competed for their party's nomination. The circle graph pie chart shows the fraction of the voters each candidate is expected to receive based on telephone surveys. If 200,000 people vote, this is the breakdown here. Okay, now, as you see here, these numbers are a little shifted. But what I'm going to do, I'm going to write the numbers where they're supposed to be at. Like here, this is supposed to be 1/10. I'll scratch that out. This is supposed to be 1/10. And I'll scratch that out. And this is supposed to be 3/20. So the numbers have shifted a little bit. So the purple and the sky blue color, they have the same value. And then also this other portion here has 3/20. Okay, now the first thing I would like to do before we start this problem, let's take the prime factorization of 200,000, because I think that will come in handy. So let's just do that real quick so we don't have to do that later. 200,000, we know 5 can go into 200,000. 5 times 40,000 is 200,000. 5 is prime, the 40,000 is not. 5 times 8,000 gives us 40,000. 5 is prime, the 8,000 is not. Now 5 times, what's that? I believe it's 5 times 1,600. 5 is prime, 1,600 is not. Okay, 1,600, we could take 5 times. 5 goes into 1,600, 320 times. So 5 is prime. Now we go to 320. 5 times 64 gives us 320. And 64 breaks down to, we could break this down to 2 times 32. And 32 breaks down to 2 times 16. And we could break 16 down. We could break 16 down to 2 times 8. And 8 breaks down to 2 times 4. And 4 breaks down to 2 times 2. So now we have a lot of numbers here. And remember, this is actually a 4. We do have a lot of numbers here. Let's look at how many 2's we have. We have 1, 2, 3, 4, 5, 6 2's. So we need to write that out. I say we could write that over here. We have 6 2's. That's 3, 4, 5, 6. And we have 1, 2, 3, 4. It looks as though we have 5 5's. We have 1, 2, 3, 4, 5 5's. So we have 5 times 5 times 5 times 5. So we have 6 2's and 5 5's. Okay, that's the prime factorization of 200,000. It says, how many votes would Mr. Williams expect? Now, Mr. Williams expects 1/4 of the vote. So it'll be 1/4 times 200,000. So now we'll put a 1 under the 200,000, and we would take the prime factorization of 200,000, which we know is 6 2's, and then we have 5 5's. And that's divided by 4 breaks down to 2 2's. These 2's will simplify each other out. So we would have, our denominator would be 1, and then this will end up being 50,000 when you multiply. So the answer would be 50,000 votes. That's what Mr. Williams would expect, 50,000 votes. Okay, now we scroll down here to B. How many votes would Miss James expect? Okay, now Miss James, I have to go back up here real quick. Miss James would expect 3/20. So now, we have 3/20 times 200,000. And we'll put that over 1. 3 is prime, and 200,000, we know we have 6 2's and 5 5's. And that's divided by 20 breaks down to 2 2's and a 5. So we have 2 sets of 2's that simplify out and 1 set of 5's that simplify out. Now we have to multiply this out. Okay, so this will end up being 30,000 over 1. So Miss James can expect 30,000 votes. Number 4, it says find the perimeter and area of the rectangle. So what I'm going to do is this here. I'm going to do the perimeter. So we will have perimeter is equal to, now this is a rectangle, so it'll be 2 lengths plus 2 widths. 2 times the length plus 2 times the width. So perimeter is equal to 2 times the length is 5 6 plus 2 times the width is 3/8. Now remember, this is assumed to be 2 over 1. So we could do 2 times 5 all over the prime factorization of 6 is 2 times 3 plus, in our numerator here, we will have 2 times 3. And the prime factorization of 8, we know is 3 2's. These 2's simplify, and you have 5/3 plus these 2's simplify, and you have 3/4. Now we have to find the common denominator of 3 and 4. Now we'll do the prime factorization. 3 is prime, and 4 breaks down to 2 times 2. So our LCD is 12. because it'll be 2 times 2 times